Walk into any modern enterprise, and the pressure is palpable. You must deploy automated decision-making and security systems across your infrastructure, or risk falling behind. The pitch is usually the same. Plug in the AI, eliminate your team's manual workload, and let the algorithm flawlessly separate safe operations from dangerous threats. The challenge begins with the data itself. When information is incomplete or contradictory, it creates a logic gap that no algorithm can bridge on its own. We see organizations struggle with this across the board, deploying high-level strategic AI, configuring network security, or managing IT administration. This diagram shows the mathematical reality. You have a distribution of normal, benign activity and a distribution of malicious data. Because safe and dangerous inputs often share identical characteristics, they overlap right here in the middle. The system cannot tell them apart with certainty. If you tune your system to be highly sensitive, moving the threshold to catch every conceivable threat, your algorithm will trigger an avalanche of alarms. Catching everything requires a massive increase in human labor to investigate all those flags. If you drop the sensitivity to save your team from burnout, the math guarantees that real threats will slip through undetected. There is no magical setting. You have to make a hard operational compromise. In practice, automation functions as a mechanism for shifting resources. You are exchanging generalized human effort for the specific manual management of operational risk. Let's look at how this plays out at the strategic level, where AI is evaluating multiple criteria to route global supply chains or design smart city infrastructure. When data is uncertain or conflicting, systems rely on a process called evidential reasoning. Instead of forcing a rigid binary yes or no, evidential reasoning synthesizes diverse inputs to produce a nuanced confidence score. It tells you how strongly the available evidence supports a specific action. The trade-off is that a confidence score is not a final decision. You still need highly paid human domain experts to interpret those scores and weigh the context to prevent a major strategic error. Relying on human oversight keeps your organization safe, but it significantly reduces the execution speed often associated with AI. To calculate the exact return on investment of these automated systems, data scientists use what this chart shows, a confusion matrix. A true positive happens when the system correctly catches a real threat or identifies a genuinely profitable strategic move. A true negative is when the system correctly ignores benign data, functioning quietly in the background without bothering your human operators. Those two outcomes are the goal. However, the true financial and operational cost of your system is entirely determined by how you handle the errors in the remaining two quadrants. Let's drop down to the technical level and apply this matrix to network security, specifically intrusion detection systems. If you tune your detection system for maximum security, you will generate a massive spike in false positives. The system flags normal, everyday network traffic as malicious. This creates a direct financial tax, as you must dedicate a larger portion of your budget to the manual clearing of these false alarms. Conversely, tuning the system to run quietly guarantees a rise in false negatives. Actual attacks slip through, creating an undetected security risk you might not discover until the damage is done. Now consider the sheer volume of daily operational data that an IT administrator must sort through. At the operational level, managing identity and user directory systems creates the exact same threshold friction. Enforcing strict granular roles, manually separating front office users from cashiers or guests, prevents unauthorized employees from accessing compartmentalized data. But that level of precision creates a bottleneck. Every minor password reset or role modification requires manual help desk intervention, increasing the total time spent on administration. Across AI, security, and IT administration, prioritizing absolute safety creates a cycle of constant human intervention that offsets the speed gained from the initial automation. The most effective organizations stop searching for a flawless algorithm. Instead, they carefully match their system parameters to the reality of their human resources. This flowchart illustrates the primary calibration question every enterprise must answer before deployment. Do you have excess human capital? If your team is time-poor or budget-conscious, you need to lower your system sensitivity and avoid over-segmenting your user groups. You must explicitly accept a higher risk of undetected anomalies. This is a necessary trait to keep your limited staff focused on high-priority threats instead of chasing ghosts. If you are a risk-averse organization where a single error is catastrophic, like healthcare or critical infrastructure, you must invest in high-sensitivity systems and nuanced evidential reasoning. Understand that for these high-stakes systems, the true financial investment is the payroll required for human domain experts to process the resulting volume of false alarms. Setting these policies is a severe executive responsibility. You are defining exactly how much friction your organization can tolerate. System reliability depends on identifying exactly where the math reaches its limit and positioning a human expert to take over at that specific threshold.